Okay, this one is tutorial 11, nuclear and particle physics. We start with objective question. The difference between the sum of masses of individual nucleons. Okay. Yeah. Individual nucleons that forms atomic nucleus and the mass of the nucleus is called. So maksudnya kalau setiap satu tu kan, ni soalan ni maksudnya for each one of these individual tu dia kamu tambah ada difference dengan total mass of the nucleus. Kenapa? Apakah itu? Boleh pandai satu. A. Okay. The difference is because there is mass effect. The question number 2. When P decays to S, which of the following particle is emitted? So to solve this one, normally you would like to write down the equations lah. So contohnya macam P3215, this is the parents punya nucleus, and then they produce total S32 and 16. Okay, so you want to identify what are the other particles. So here you can try to do conservation on top here, numbers kat atas ni dengan nombor kat bawah ni. Okay, up there you have 0 to balance, and then down here you should have -1. Okay, so 0 and -1 means this one is electron. And then question 3, half-life is the time interval required for the numbers of disintegration per second of a radioactive material to decrease by half. 1/2 lah. Okay, senang soalan ni. So question 3A, can you find what are the 2 basic types of particle accelerators? Dah tengok belum video? So apa 2 basic types yang kita belajar?
Linear dengan circular.
Yes, linear and circular. So linear acceleration and circulation. Linear accelerator dengan circular accelerator. Question number 5, which of the following is not a fundamental particle? This one, actually the answer is C, hadron. Because hadron ni dia consists of quarks. So dia bukanlah elementary particle. Dia ada particle lain dalam dia. Dia consists of something else. So maksudnya kalau fundamental particle ataupun elementary particle dia tak ada lain lagi. Kecil lah. Dia asasnya itulah dia. Satu betul saja. So contohnya macam quark berwarna elektron, itulah contoh elementary particle. Okay, we start with calculation. Question number 10. Question number 6 until number 9 tu is either we discuss already ataupun sebenarnya senang lah. Okay, this one dia kata 21580. The half-life is 100 microsecond and then 5 gram. Okay, so first of all you take out the information. So it's 21580. Half-life is 100 microsecond. Okay, then this sample contains 5 milligram of the element. Okay, so if they give you mass, most likely you have to find n numbers of nuclei from that particular mass lah. So m is 5 milligram. Normally I will write this one in grams saja. Okay, the first question they want you to calculate the initial activity. Okay, initial activity simbol apa yang dia nak cari?
A0.
A0. Okay, very good. Okay, A0. So for the mass, and if they give you the symbol here, kan, you can straight away find the n. Okay, so the step to solve this one is number 1, you have to find n. Okay, and then once you get the n, you want to use relation between a and n. A is equals to lambda n. Obviously, you still have to find the values for lambda as well. Okay, we start with lambda. I think that was the easiest. Lambda is equals to ln 2 over t half. So basically we want to find n and lambda. Ln 2 over 100 times 10 negative 6. That one is in second. So be careful with the unit. So if I do that, I should get 6.931 or 6931 lah. What's the unit for lambda?
S negative 1.
Yes, very good. S minus 1 per second. So N is equals to mass divided by molar mass. You will get numbers of mole. Okay, and then you have to multiply with Avogadro's number so that you can get numbers of nuclei, which is equal to numbers of atoms. So Na is equals to mass is 5 times 10 negative 3. Okay, remember yang numbers yang 215 tu, this one that one unit dia adalah gram per mole. So if you want to straight away use the 215, you have to change mass to into gram. Avogadro's number 6.02 times 10 to the power of 23. Numbers of nuclei is equals to apa ni? Dia dapat belum?
1.4 times 10
Okay, very
power
good.
19.
1.4 times 10 to the power of 19 nuclei. Unit ni ada nuclei lah, numbers of nuclei. Okay, so now that you have lambda and n, you can find A. Okay, so in the mass 5 gram to means the mass of initial sample. So if I write down n is n naught, that means my A is A naught as well. Skinny n naught. So will be 6931.47 multiply with 1.4 times 10 to the power of 19. We got 9.7. 0 times 10 to the power of 22. Where's the unit for A?
BQ.
Yes, becquerel. Okay, BQ. So the question doesn't ask you to calculate in different units, so you just leave it as it is. Tak ada cakap kan? So biar je lah. Okay. That one is the answer for number 10A. For number 10B, they want to calculate the activity after 400 microsecond. And now they give you time, and they want to find the activity. You do have the A naught, so you can use A equals to A naught exponent negative lambda t. So when they give you with respect to time, most likely you have to use this equation lah. Ada libatkan time tu. A naught is equals to, sorry, this one is A naught. A naught is equals to 9.7 times 10 to the power of 22. Okay, make sure you try to solve this one using calculator. Try to press it yourself. Takut tak dapat convert. The time taken is after 400 microseconds. Okay, selalu student terlupa bila tekan calculator is the negative tu. Okay, make sure kamu jangan terlupa lah. Got here 6.06 times 10 to the power of 21.
Sama sir.
Sama good. And then since the question doesn't ask you to change or to convert, just leave it as it is. Okay, that one is for question 10. Question 11. Suppose that the probability that each nucleus will decay in 1 second is lambda is equal to times 10 negative 6 per second, and the numbers of nuclei in the sample is 5 times 10 to the power of 9 nuclei. Calculate the rate of the decay. Okay, yang tu dia dah kata lambda dia dah given. Lambda is equal to 1 times 10 negative 6 per second. Numbers of nuclei in the sample, that one is your N lah. They want you to calculate, this one is nuclei. They want you to calculate the rate of decay. The rate of decay simbol apa yang dia nak say?
DN over DT.
Yes. It will be dN over dt. So maksudnya within 1 second berapa banyak N yang berkurang. Ataupun in this case decay lah. So dN over dt is equals to lambda N. Jadi ada negative actually but then I just leave out the negative. I just use the positive for calculation. So 1 times 10 to the power of negative 6 multiply with 5 times 10 to the power of 9. So 9 minus 6 is 3. So my dN over dt is equals to 5 times 10 to the power of 3. What is the unit for this one? This sama dengan A kan? So factorial activity. Okay, any question on this one? You guys
No,
clear on this?
Yes.
No, sir. No, sir.
Yeah, B pula. Okay, again they give you mass. And then kita rather than 2 to 6 to the punya gram combo lah. Then measure the rate of 9 times 10 to the power of 11 per second. Calculate the decay constant of the radium. So first thing they give you mass. Okay. But this one in kilogram, so normally I would like to use gram. So it becomes 0.25 times 10 negative 3 gram. Why do I need to use in gram? Because I want to have the same unit there with the molar mass 226 gram per mole. Emits alpha particle at a measure rate of 9 times 10 to the power of 12. Itu dia punya apa? Simbol apa kita nak represent 9 times 10 to the power of 12 tu? Rate. And they want to calculate the decay constant, which is lambda. Okay, back to my question. 9 times 10 to the power of 12. Simbol apa kita nak represent benda tu? Rate of alpha.
A, sir.
A betul? A betul? Or I think this one maybe you can write down the NDT ke. Sama, the NDT tu sama dengan A lah. Okay, anyway. You use the same equation as previous one. The NDT equals to lambda N. Okay, but remember, if you want to calculate N, you have to use mass divided by molar mass multiplied with numbers of Avogadro number. So I'm going to calculate everything at once. So lambda, ini cik lambda, sorry. Patut lambda tadi. Okay, so the NDT dia adalah 9 times 10 to the power of 12. Lambda. N dia adalah mass 0.25 divided by molar mass. Okay, alternatively you can convert molar mass to jadi kilogram lah. Boleh je. Okay, kita check balik Kita check balik yang ni. This one given in kilogram. If I want to convert to gram, it will be power of 3. Minus 3. So this one will be power of 3. Now I got the answer. Okay, unit per second. Okay, dapat kan?
Dapat sir.
Alright.
Dapat, sir.
Now kita try tengok the next question, question 12. Dia kata half-life of radioactive nucleus 226-88 is 1.6 times 10 to the power of 3 years. If a sample initially contains 3 times 10 to to the power of 16 of such nuclei, determine the initial activity in Curies. So here dia cakap lah, dia nak dalam CI T half is equal to 1.6 times 10 to the power of 3 year. Initially, sample contains 3 times 10 to the power of 16 to the punya, and sebab dia nuklear kan, not sebab dia initial. So 3 times 10 to the power of 16 nuclei determine the initial activities in Curies. So you can use A naught equals to lambda n naught, where your lambda is equals to ln 2 over T half. Okay. So if you want to get the final answer per second in becquerel, before kamu convert ke CI kan, kamu dapat BQ dulu. T half tu kamu kena buat dalam second. Multiply with n naught, 3 times 10 to the power of 16. Therefore, A naught sama dengan ln 2. Okay, T half dia adalah 1.6 times 10 to the power of 3 year. Multiply with 365, kamu dapat dalam days. Multiply with 24, you get in hours. You multiply with 60, and then 60 again to get in seconds. Okay, so your A naught is 4.12. Nampak tak? 10 kuasa 5.
5.
Dapat
Okay,
success.
dapat sama.
This one in becquerel, per seconds lah. Okay, but you want to convert to Curies. And you know that 1 Curies is equals to 3.7 times 10 to the power of 10 becquerel. Betul tak? Okay, you can cancel out. You do cross multiply so that you can cancel out the becquerel. So here I got 1.11 times 10 negative 5.
Sama, sir.
And then the unit will be CI. Okay. 12 done. Okay, now question 13. Suppose the decay constant of radioactive substance A is twice the decay constant of radioactive substance B. Decay constant simbol apa kita nak pakai?
Lambda.
Lambda. So dia kata lambda A ni 2 kali ganda daripada lambda B. Maksudnya kalau lambda B saya adalah lambda, lambda A saya adalah 2 lambda. If the substance B have a half-life of half-life of 4 hours, what is the half-life of substance A? Okay, so basically I can write down T half untuk A is equals to 2 over lambda untuk A. Okay. Kalau T half untuk B, basically it will be ln 2 over lambda B. Okay. Kalau untuk B, dia T half B sama dengan ln 2 over lambda. Lambda B dia sama lambda kan? Dan ni yang ln 2 over 2 lambda. Okay. I can factorize the ln 2 over lambda tu. Kalau saya nak tukar calculator kan, saya factorize. Jadi, saya tulis kat sini 1 over 2 ln 2 over lambda Okay. Ln 2 over lambda ni sama dengan yang kat sebelah ni lah. Which is T half B. Obviously, alternatively kamu boleh tekan B tu terbesar. Obviously, alternatively you can do simultaneous equation and then you can solve T half tu berapa. Ini adalah 4 hours, right? So 4 divided by 2.
Dapat sir.
Okay. Alright. That one is for question 13. The next question is question 14. The isotope 57CO decays by electron capture to Fe with a half-life of 272 days. Kadang-kadang dia suruh tulis apa tu equation. So kalau dia suruh tulis, kamu kena fahamkan lah yang dia cakap tu apa tadi tu. Ini tak suruh So T half dia adalah 272 days. The Fe nucleus is produced in an excited state and almost instantaneously emit gamma ray. So daughter dia adalah Fe and then they produce apa tu gamma ray as well. Find the decay constant for 57CO. Decay constant is lambda, so lambda is equals to ln 2 over T half. Straightforward soalannya. T half dia adalah 272 days, right? So you have to convert to hours and then minutes and second. So my lambda here is equals to
2.95 negative 8
berapa?
second.
2.95. Okay.
2.5 exponent negative 8 per second.
Okay, very good. 2.95 times 10 negative 8. Okay, the unit will be per second. Okay, the next one, if the activity of a source is now 2 micro Ci, how many nuclei does the source contain? Okay, this one dia kata A not dia. Dia A not tu sebagai at that moment lah, at that particular time. Kalau A pun boleh juga kamu cakap A kan. Tapi sebab soalan yang last tu kata after 1 year tu. After 1 year tu from this moment. So this is the initial one lah. So A not is equals to 2 microcurie. And then they want to find the how many nuclei that the source contains. So basically they want to find N. Okay. So if I want to find N, I can use A equals to lambda N. But remember, because my lambda is in per second, so my A not actually I have to use per second as well. Becquerel lah, digit per second. So I have to convert. Tadi kita tahu yang 1 Ci ni, tadi kat atas kan, 1 Ci is equal to 3.7 times 10 to the power of 10 bacterial. So just copy this one. Okay. So if I want to change the bacteria, I just have to multiply. 2 exponent negative 6 times 3.7 exponent of 10, I got 74,000 becquerel. Okay, now if I want to use A equals to lambda N. So my N naught is equals to A naught divided by lambda. Kalau here 2.51 times 10 to the power of 12. Okay, unit dia apa?
Nuclei.
Okay, nuclei. Good. Okay. And last question here, Kata what will be the activity after 1 year? Okay, see, if they ask you to find after certain time, most likely you have to use yang A equals to A naught exponent tu 1 year, and they want to find activity, so you have to use A lah, A equation. Kalau dia cari nuclei, N equals to N naught. Okay, then kadang-kadang dia tak, soalan ni macam kadang-kadang tak guided tau. Basically dia tidak ask you to calculate lambda first. Dia straight away suruh kira benda ni. So dia straight away kira benda ni, you can try to do lambda ni, unit dia sama dengan T, should be okay. Contohnya kan, kalau time ni saya tukar dia sebagai days, so lambda tu adalah ln 2 over T half kan. So kalau T half saya dalam days pun boleh sebab dia potong. Okay. Kalau lah. Tapi in this case dia memang suruh kira, so we use everything as a unit. So A naught tadi adalah 74,000. Lambda kita dah kira tadi 2.95. Ada times 1 year, so 365 saya nak tukar per seconds lah. 1 tahun dah 355, dah 24 hours multiply with minutes and second. So after 1 year, my activity now becomes ini 2.95. Exponent is 2.92 times 10 to the power of 4. Dapat tak?
Sama sir.
Sama ya, good. Okay. Any question?